Welcome class, Dr. Mike here for Python CIS 2266, and this is topic 3, and it's Python order of operations, booleans, conditionals, control flow. So a lot of aspects of this week, and this is really going to start digging into the meat and potatoes of Python. So previously we talked about some variables and statements. Again, I don't plan to go over all the existing videos that came with the textbook, which is Python for Everybody. This information also is also embedded in using the shell, or you can of course download the PDF. So I definitely suggest you download and find these references and use them for your work. What I'm going to do is I'm going to give a quick demo that will explain some of these concepts, and we're doing it in a game. So what I'll do is I'm going to create a new, I have Jupyter running here. I'm going to create a new notebook, and we'll just call it week 3 game. And again, we'll call this here, we'll make this a markdown, high-low game, high-low. So I'm going to go over some concepts here too that we're going to see more and more. This first one here, of course, being something that I'm just going to briefly show you, but we're going to come back and see again, and that's importing libraries. So just briefly, a library is just a software. It's a more Python code that's usually stored out that you can bring into your notebook to expand sort of its power base. We'll see in the syllabus later on, we're going to talk about libraries, NumPy, Matplotlib, Pandas, and we'll see some more libraries down here too. But for now, we'll keep it this way. Libraries are imported with the import statement. Now, you see it import, and it turns green in this case, in bold, telling me that it is a keyword, an actual expression. Now I can import a library, and usually you just import something as something else. But also, you might see this used here. We're going to use this for the game. From random, and hit the tab key there. Import, again tab key, so a little drop down there. Tab key. So the idea here is I don't want to import the entire random library. I want to support a part of it, which is random int, random integer. The key here is encoding in general is you don't want to bring everything into you don't import everything because you have a very large bloated program then, whereas you have a lot more efficient on the computing side just to import what you need. So again, I'm going to start my game with this. We're going to see import and import from, and from something import something a lot more in the course, so I don't want to spend too much more time on this. We're going to run that. Again, I don't get any error. That means it worked. So what we're going to do is we're going to create a game. So the game's going to have, do this. I'm going to do this. I'm going to create my notes here. The game itself, it's going to get a random number from 1 to 100, and then it's going to get a guess from user, and it will test it to see if is it too high or too low, and we'll get some sort of feedback to help them guide to see if they can guess a number. So, all right. So again, these are my notes here. So I need to create some variables. I'll need to have a count. Maybe I want to stop after so many times. Then I want to have, of course, the guess, and this will come from input. So our input, and of course I need a random number to guess against. So in any case, again, I ran this cell. It's all comments. These are just my thoughts I put down real quick here. All right, so first off, we're going to go and change a random number. So first off, let's create our variables. I mentioned before, you don't have to initialize the variables. I like to sometimes, and there's sometimes when it makes sense to, because, well, a lot of times when you initialize a variable, maybe it's a number variable, it will start at 0 and actually won't start at 1. This comes into fact, we talked about counting the number of guesses. If we just take and start at 0, your first guess as a user will be guess 0. And it can be a little confusing, like, well, I did 4 guesses, why does it say I only did 3? Well, you did 4, 0, 1, 2, 3. So in this case, I do want to initialize a variable called count. All right, C-O-U-N-T, count, and it's going to equal to 1. So I'm going to sort of set it up initially. Then I'm going to call it guess. Guess I'm going to equal to 0. Now I'm doing some stuff in this game. I'm not going to do anything that's called input validation, where I otherwise say, please get enter a number between 1 and 100. I'm not going to check that. If you do program, you design programmatically, sometimes you want to verify inputs, either from a user or maybe from a file. I'm not going to get that level of coding here in this demo here, but you can see where you want to maybe put that in place for an actual game. So if someone puts in the letter 10, they had to type out 10 instead of put number 10. You can say, please enter a real value. So, and then we'll call it random. Oh, rando will be our number. We'll set to 0. We're going to actually fill that in. I'm going to do it right now. So we need to actually generate our random number. Generate rando. So I'm going to call this library up here, random init. Don't worry about too much about how we do it yet. What I'm doing here, rando equals random init between 1 and 100. Just a summary again. From random, I import random init. I'm going to say, hey, run random init. Give me a random between 1 and 100 and put it in this variable. So, and I'm going to cheat here. I'm going to print rando, just for the fact so I can test out my game. I don't want to actually sit here and play the game in front of you so you can see how bad I am at guessing numbers. All right, so start the game off. So again, I need to generate a random number. That's been done. I need to get a guess from a user. So let's go and generate our guess. So guess, which we know is a variable we already did, equals. Again, we saw from last time, I actually want to wrap this in an integer. I'm going to force this into an integer. So remember, when someone does a input, that gets pushed to a string field, a string variable type. And I want to take that string, I want to convert it into an integer. So in some ways, it might do some syntax checking for me, but if someone types in the word 10, T-E-N, and it tries to make an integer for me, that might not work. But again, let's not worry about input validation for now. We'll just say integer. I'm going to do an input field. I'm going to say enter a number between 1 and 100. So I can have this in a separate field if I want. If I want to, I can run it and check it. Put 42. Again, no error, but let's print it out just to verify. Let's print guess. Run it again. 42, 42. So echoing back, the input might be a good idea, just so that people can see what they entered in case they forgot. So we can make it a little more fancy here if we can put this print enter you guessed. There we go. So run it again now. Let's do 55. You guessed 55. So in any case, you can have some fun with it. Now I can keep coding in the same block, but I'm actually going to write the next chunk of code in a different cell. So, so now we actually guess too high, too low, or I should say, or correct. So I mean, that's the conditions we're going to see, right? So again, not going to the textbook here, we're going to do some basic mathematical comparisons here. We know we have an integer, that's in this case 55, the current guess. So first thing is, did they get it right? So our first statement we're going to talk about is the if statement. And a simple if statement is that it's going to check a condition. So if guess is equal to rando. All right, so a couple things here are note. First off, this is my check. If my guess is equal to the random, hence is this equal to this? And notice I don't use the equal sign individually, I use a double equal. So when evaluating numerically here across with a comparison, and we'll see, again, you see this in the Python for Everybody text. When we look at conditionals, right, there's your table. Is something equal to something, you use double. You can see you can do less than equal to, greater than equal to, or less than equal to. It's important to consider when you design how important it is, this little single step here. Like for example, if I was doing some scientific data comparison and I said if temperature is greater than 100 degrees Celsius, you want to ask, well, do we want to evaluate 100 degrees Celsius? Do we not? Because if we leave at 100 degrees Celsius, you could be dropping off a large chunk of the data that you actually might want. So you can see with that little equal to or not equal to, greater than 100 degrees or greater than equal to 100 degrees. So again, and then you can see here this if statement here. So if it's equal to this, it's positive. So go back to our game here. So if guess is equal to rando, so again, let's go back to this. If guess is equal to, again, my tab key rando. Now I do the colon here, hit return. You notice it does the tab for me. This is important. Don't just hit return and backspace. Python uses this sort of 4 spaces here as the conditional bracketing. In a lot of programming languages, they use these good old squiggly lines here. They'll use this to sort of indicate the start and end of a bracket. Python doesn't use any kind of brackets or semicolons, things like this that are used in a lot of programming languages. If you're not sure, maybe you misclicked, hit backspace, you go, uh-oh, shoot, you can see it's already red, and it's not going to work. I said just backspace, back up to here, hit return again. It should do the indentations. Indentations count. And again, the way to kick off the indentation if statement is this colon is sort of the indication that it's the end of my if statement. So if this is true, do this. Print, you win. There you go. All right, so again, otherwise it didn't do anything. So again, it ran, it doesn't equal it. Let's see if it does. Let's test it out. So let me run this again. Let me enter that 24. And let's go and run this. Oops. Now let's run this. You win. So again, if this is one code block, it'll run at one time. I broke into separate cells just so I can run chunks at a time. I mean, at the end of this, I'll put it all together into one single script. But for now, you can see how I can go back and run this and test it. So if we generate our random number, now it's 7. If I do 10, I get nothing. So that's the if then else. If you want to say, I'm sorry, you did not get it, then print something else. So we can add that else here if we like. So if I wanted to, we can see by the syntax here, it is back over to the same level, indentation level as the if. So else, print, nope. What do we want to do? So if I run it again, I get the nope. So in that case, this is up to you in your design, if you want to use if then else or just if not. So for now, let's just leave it off. If you didn't get it, I don't need to tell you you didn't get it. I'm just going to tell you right away. The next step in my game is tell you whether you got it too high or too low. So, all right. So for my notes here. All right, so we're going to write another, we're going to take that else statement here, and we're actually going to expand upon it. The idea here is you didn't guess it right initially, so let's go and jump into our first else statement. Else, and we're going to do another check here. If I wanted to, I could actually say you only have so many guesses. I'm actually going to do that here. So, and this is using loops. So, which I believe, yeah, operators, conditionals, control flow. So we can do this right here. Is equal to else if ELIF. Yes, that's not spelled incorrectly. We can just do a quick check and come back and tell them. We'll start with that. Let's go and do it that way. So else if guess, I'll skip the loop for now. That's where the guess, the count comes in. So if the guess is less than rando, we can print too low oops, again, if you messed up like I just did, just there you go. And then again, the else if. So we can build this little structure here. Else if guess is low. Else if is guess, oops, is guess greater than rando. Print too high, right? So you can build this structure like that, and then you can see it here in the text. And this is where you can use the conditionals to evaluate. So right there, you can put this statement and this control flow into the game. So, spell it correctly, too high. So again, you can see here my guess was 10, it's too high. Let's put another guess here. So again, let's regenerate a random integer here. In this case, 98. Let's put in again a guess of 55. Oops, enter. And if I run this, it's too low. So again, I got one try. If I wanted to, let's go ahead and talk about, we can use the count if we wanted to. You could put in a while loop. And I'm gonna leave while loops out for now. I don't make it too complex. We'll come back and look at this. We'll reapproach this again when we look at looping. For now, I'll keep it simple like this. So again, for now, I don't need the count variable, so we'll just ignore that, which is fine. You don't need to use it. Normally, what you can do is you can build a while loop and then create a counter and say you get 10 guesses and count to 10, and then each time they guess, you tell them too high, too low, try again, try again. For now, though, you know what? We're just going to forget about the count and keep it simple. So again, pretty straightforward here. We created a random number. In this case, we printed it out, just a cheat to test our inputs. And we got a guess between 1 and 100. We got the guess from the user input. We echoed it back just so they can verify it. And here we can test if they want or not using this if or else if framework, which is right here. It's called nested conditionals. So let's actually get it right. Let's actually do it again here. Let's run this again. We got 30. It's here, 30. And we can run it and we won. So yay. Now again, if you wanted to, I could take all this. I could take this, put into here. I could take this, I'm copying and pasting, Let's not print out the random integer. And you can put some spaces between your code if you like, just blank spaces, sort of logic, you break it out. There you go. Now if I run this block, I don't have any guesses. I don't know what's going to be. I'm just going to change it. So I don't know, say 55, too high. If I ran it again, I'm not going to be all day trying this. Too high, wow. So you can see how it actually would work. And we can actually create a loop so you can keep playing the game under the same guess also. Again, we'll come back to looping later, but for now this is probably pretty quick here. I think this really covers what I want, which is the if and else if and conditional statements, which is of course the equals to, less than, or greater than. And again, like I mentioned before, with conditionals, pretty important, this operating table here. How you use this when you get to look at scientific operations is important. Again, if you're told to get everything that's 100 degrees or above and you do just greater than 100 degrees, you forgot the 100 degrees then. So this is where a written requirement, it can come from a researcher, it can come from software. When it goes into software, that small little mistake, which is a logical mistake, it doesn't cause any programmatical errors, but it will cause our output data to be incorrect. And it won't be until some verification later that we don't have any 100-degree marks. So I wonder why that? Well, it's because we don't have equal to. So in any case, quick little guessing game here. A couple other tips there, of course, you can see is using your tab key to help either auto-fill in names of variables and or code itself, or things that you can call. So that tab key is very handy. And again, very important is when you do create a structure like this, let the Jupyter Notebook do the annotations for you if at all possible. If you do think it's messed up, luckily in some ways it will tell you, and it might not, so the annotation errors, so right there. So if you get the annotation errors and you think it looks correct, why is it not working? Best thing is a backspace up to the previous line, hit return, and it should drop it into the correct annotation where you don't get the error anymore. Anyways, that wraps up a quick look at a high-low game, which does cover a few of the conditional flows, Boolean, especially operators. Control flow get a lot deeper, a lot more deeper, and we're going to explore control flow and looping over and over again, especially as we move through. As we get to ingesting data, we're going to be looking at looping and things like that. So we're going to be approaching this syntax and the use of Jupyter Notebook throughout the course. Again, if you'd like to go ahead and try this at home or try yourself in your own notebook, feel free and create your own game. That's it. Thank you.